Welcome to XR Talk Show. Today is June 26th, 2019. Today we are going to do live coding of JavaScript or Emacs Lisp or Golang. So which one to do? You know, let me know. Type in the comments which one to do. So let me get ready, pop this out. We're gonna do live coding. Today, live coding one of JavaScript or Emacs Lisp or Golang. Type here to let me know which. Okay, so before nobody's here yet. So before we start, let us this is Sparks music. I talked about it yesterday. This is fantastic. The most cold and austere music there is. Mathematical perfection. That's what they say. The common comment about that. So let's do either Golang, JavaScript, or Emacs Lisp. We're gonna do live coding of that. But meanwhile, while I wait for people to come on, let me just talk about some random things, programming related, basically. So first of all, XR start. Let me show you this. Okay, since we are in Emacs, so we're gonna do XR start command log mod, so that you see all the command I call on the left window here. Okay, now this code is TypeScript. TypeScript is a statically typed JavaScript wrapper. That's basically what it is. It is greatly useful when you have lots of code, when you have thousands of lines of code. Typed language versus dynamic untyped languages. I usually, when I was younger, like 10 years ago, or from 1990s, I always preferred dynamic languages, without type, because I thought that that is more natural, more human. For example, in math, you don't say, when you say x equals to 2, you don't say, oh, x is a type number, you know. But actually, there's more detail to that. But anyway, so I thought dynamic, not typed languages is more natural. You shouldn't need to declare variables with a type. That is actually a byproduct of computer engineering. Hey guys, so we're gonna do one of JavaScript or Emacs Lisp or Golang. So please type in your comments. Let me know which one you would like to see, because that's what I announced. But since I'm waiting for people to come on, and just going to, I was talking about random things, typed versus untyped language. So here is TypeScript. Now, so I was saying, when I was younger, I prefer dynamic, without types, because I think I thought that is more natural. As an example, in math, you don't have to declare types to define variables or functions. But there's more detail to that, actually. But anyway, so it's more natural because and I thought the thing is that I thought typed languages are, for example, C and C++. These are the worst. Everything that's wrong with computer science, with with the programming industry, began with C. Yeah, then C++, then Java, then C Shell, then Perl. Uh, so why is it unnatural? Why is typed unnatural? That's a byproduct of computer engineering, which is like C, programming language, C or C++. Like when you have to do variable, you have to declare a variable is like short, int, long, double, float. What the fuck is that float? Yeah, and also with the the jargon they've chosen to use. Int is integer, right? But then you have float type, which is, it's very interesting if you study the etymology. Float, double. Why would they name float and double? Like in math, there's no such thing. They are real numbers, but there are integers. Which is 0, 1, 2, 3, and negative 1, 2, 3, so on. And they are real numbers. Real numbers are like a elastic band. You have an elastic rubber band. There's an infinite number of them. So, and real numbers are usually represented when you write it out. It's represented by decimal notation, like 3.1, 234. So in math, there is no such thing as double. So, but why do we have the name double and float? Well, the reason, first of all, you have float. The reason the C, programming languages have that is because you have to represent numbers in memory and in CPU, and those are just electronics on and off. So in other words, it's binary system, and you cannot represent. Yeah, actually, so this is actually a deep problem. You see, the problem is that you want to represent a real number. How do you do that? Well, on paper, we can, say we can use a fraction, we can use a decimal number, or we can actually use, let's say, we can write square root of 2. That is the real number. You see, this is math, real number. But if you want to represent on a computer, you don't really write square root of 2. Square root of 2, it's like that's a number, you have to compute it. And many real numbers. So that is the question, actually. You see, this actually, this is a very interesting question, because the question is, how do you represent real numbers? You know, we are taking this into a philosophical context. I mean, in general, like how do you represent the real numbers on paper, by mathematicians, or by common people? What do they need? Are there real numbers they don't need? Or then, as far with respect to programmers, how do you represent real numbers? Let's say, how do you represent real numbers on abacus? So the question immediately becomes, then we have to ask, what kind of real numbers you need to represent, because real numbers, there are lots of. Anyway, I digress a lot. So anyway, the C and programming languages, they have the float. Well, the reason is float is because they want to they are not actually real numbers. You see, the float, they are just a number, a decimal number. They are actually fractions. Technically, mathematically, they are actually fractions. They are real numbers. They are real numbers represented by fractions. In fact, so the numbers, in computer languages such as C, they only represent. They don't have all the real numbers. It's impossible to write any real number. You can only have basically fractions, and basically any fraction, the subset of real numbers that can be represented by a fraction. You take that fraction, then you convert it to binary numbers. Then you store that into the CPU or memory. One on and off, and so on. So they name it float. Well, the reason they name it float in C is that it's represented by, you have they are trying to represent the binary, a sequence of binary digits with a point in between somewhere. So the float is actually, like, indicates where that point is at. So I think that's why it's called float. in the beginning it's represented by 2 bytes, like 16 bits or something like that. Then you have double. Double means double precision. So that's why they have uh, in C you have types float, then you have double, then you have long. I think long is for integers, right? I don't remember. Anyway, it's more bits. So anyway, so I digress. Let me finish the topic. So I was talking about programming languages typed versus untyped. So I think those typed are, I thought when I was younger, the typed are unnatural because especially with C. So you have this int double float, then you have so they are like a byproduct of programming. They are like by byproduct of computer engineering. That's what I say. When you do engineering, you have a lot of byproducts. Like things you don't really want, but it is there because of the many constraints in engineering. For example, when you build a car, you have the shift manual shift, right? This today most cars are automatic. You don't have to shift the gears, but before you have manual shifting. That is a kind of a byproduct of engineering. You see, because in the very beginning you cannot, automatic shift is more complicated. It involves lots of universal gears. It's more complicated. You cannot, it was not invented. So in the beginning you don't have shift at all. Then you started to have manual shift. So that's kind of like the concept of shift is kind of like a byproduct of engineering because of limitations. We have lots of byproduct of engineering. For example, cars tires. You have to pump air every once in a while. You have to pump air, but that's like when you drive a car. Why do I want to pump the air? You don't want to, but you have to because we don't have, because we say that the airless tire. Now today they have new technology where a tire without airs, so you never have to pump it. So that is theoretically better, but I'm not sure what's the current status. But anyway, so you have to pump air into the tire. That's a byproduct of engineering, because engineering is not God. You just say, make a car and you have a car in every way, perfection. So byproduct of engineering. So I thought, the types in programming languages, the C, like the language C, int float, you have to declare types before you use a variable. That is, just a byproduct of computer engineering. Nobody, you don't need it. So this is what I thought when I was, almost in the past 20 years. But in the past 5 years, I started to like, well, not really like, but I appreciate. I'm not sure which one I would prefer, but I appreciate those typed languages, but not C. Here, by typed I mean like typed like like Golang, Haskell. Okay. Now these are more here. I started to think that typed languages are not, the way they use types in Haskell and Golang, they have what you call automatic typing, type inference. But anyway, the way you see it, the way you see it is that it's not unnatural because the static types used in Haskell and Golang, they are of especially in Haskell, they are of a entirely different nature than the types in C, C++, C, Java, those kind of languages. In Haskell, the type are they are not exactly byproduct of engineering, but rather they are part of the tool, useful tool. That is, you are computing with types. before you are computing with numbers, in C, and in numbers or strings, and you need to specify type because otherwise it's not efficient. That's byproduct of engineering. But in Haskell, type is part of the tool. You are not computing with numbers or strings. You are computing a significant part of your computing. The reason you use Haskell, the language is such that you are creating a program, an algorithm, a system based on types. So you have so how do you say um, let's say for example, let's say we have a bunch of baskets. You put fruits in, bananas, apples, you put them in. Now you have several baskets. Now suppose I say, suppose you have basket at home, and this basket can only allow bananas. If you have apples, you need to use another basket. That so every time you put a fruit in a basket, you have to, if you put it in a wrong basket, it'll just pop it out. It's a D wrong. This is only for bananas. So suppose you have these baskets, they only allow certain fruits to be put in. Now that's a pain. That's a pain in the ass, right? But however, now, you know, let's swap to the other side of the coin and look at this thing from a different perspective. Now, suppose you have this basket, just like before, they are typed. However, whenever you put a basket, a fruit, let's say banana, into the basket, it automatically, you know, place the banana, whatever you put in, apple, banana, or cherry, into the red basket that only contains bananas. So in this way, you see, this basket becomes useful because they automatically sort out your fruits. You can just dump all your fruits, banana, apple, oranges, or dump them into one place. It automatically sort them out into different basket. Now that is useful. Now you see, so this is two different ideas. So this is how I saw, how the types becomes useful, very useful in Haskell languages. Okay, so we got 3 people watching. So what we're gonna do today, we're gonna code. Let's see, we are supposed to be coding JavaScript or Golang or Emacs Lisp. So anyone got opinions? So what should we do? uh, what should we be coding? So we talked about typed languages versus untyped languages. You know, how a perspective uh, is different. But still, I mean, you see, C is still no good. C and C++ and Java, these kind of languages, their type is still, a byproduct of computer engineering. But Haskell is a different story. But anyway, so let's go back. So I was, I'm just gonna talk random things, since nobody is saying, hey, good morning, Sean. JavaScript, but I'll be watching anything. I like your basket analogy. Thank you. So yeah, okay. So let's do JavaScript because I was waiting for people because that's what we're supposed to do, And since you find it useful, so let's do that. So let's Sean. So good morning or good evening. So let's go to okay, blog. Okay, let's go to my web blog. I wrote these more things. Oh, by the way, Sean, I did JavaScript code yesterday, video. Did you watch it? The entire session, like 1 hour, is coding JavaScript, coding DOM. Writing a let's see, programming blog. Uh, let's go to Wordy blog. Okay, so So yeah, yesterday, I think it was yesterday or the day before, I did a full. I'm gonna show you. I'm gonna show you now. So actually, let's go to the blog, programming blog. Yeah. So and great. So we're gonna do another one actually. So let's go to Xali. I go to my website, xali.info, and let's go look at web dev blog. Oh, so yesterday we did this one, radial gradient generator. Can you guys see it? Yes, you can. Okay, so let's move this here. So radial gradients CSS generator. So you can click random, and you can get a code here. It shows the code here. You see random, or rainbow. Change number of colors, 3, 4, 7, and change the position where the ray come from, bottom left. And you can also change it to Lisp, and you can copy the code here. So we wrote this from the ground up without any jQuery or framework or whatever. It's pretty cool. So you have all these different radial gradient. Let's get some. Let's see, 4. Let's show some pretty. Anyway, so yeah, so we did this yesterday, and actually, TypeScript. So I was using. So that code is actually here. Oh no, this is another one. Never mind. So anyway, we did the gradient, and actually an hour ago, I woke up 4 hour ago, and I wrote up this. I was planning to do this live, but I just wrote up quickly. Let's see, how long have I been talking? So I think we're gonna do another one. So maybe it'll take 20 minutes. So I did this, just an hour ago. So this is the box shadow. So let's see, offset, blur, and then we can change the color and change the background color. The background color, let's be that. Okay, let's be darker. Okay, so now change the shadow color. Shadow, let's say red. So anyway, so we did this, but it's still not complete. We need, let's refresh. What we need is a random color box. So we need a button that says generate a random color, and we need another. Well, I was thinking we want another box that says just generate the whole thing random completely, like different offset. Let's see if we can blur and spread. Let's super blur. And also, this user interface is not so good. You see, you have this offset x and y, and then you have this offset y. You see, offset x, one is horizontal, one is vertical, but it's not natural to use, because you rather want some kind of, like people can just point to a direction. Yeah, a direction, then a distance. That's more natural. Like the xy offset, they are like a vectors. Like a mathematical idea of vectors. The first two numbers here, you can see. You see the first two numbers here. So they are like a vector. So they have a length and a direction. Like which way the shadow goes to. Yeah. So So we gonna are we go- so we I'm thinking we're gonna modify, add the random button, and or the other thing I want to do is go to, you see, this is my visual CSS tutorial. What I want to do is I want to make a dynamic interactive app for each and every one of them, so people can easily see how they work. But here's then there's a text shadow. You see, text shadow, I don't have a interactive thing. It would be nice to have. So what do you think, Sean? Should we start over? Let's do this text shadow, or should we modify the box shadowed and add a random color button? Yeah, let me know. You know, you pick is better. I feel better. How to Let's try random. Okay, yeah. So let's do that. Let's see how many people. So let's add a random button. Okay, so first of all, let's go to the my local website. Okay, so let's open a file. So this is the file. Let's show in Firefox. In Firefox, I have JavaScript off, so you don't see. This is not working. So we need to go to the Chrome. So let's go to Chrome. Close that. New tab. Paste. Enter. So here's the Chrome, and we can let's see. So yeah, so this is the source code. This is the source file for that. You can see. Okay, let me show. Um, so this section is the application, the interactive thing. So we have color picker input here. So what we're gonna do actually, so we need to, let's just add a random box instead of explaining like the whole thing. So okay, we need a new user interface widget that says random button. Okay, so let's do that. We need a button element, and over here, yes. So button, and type equals to, you have to say type equals to button. Random color. Okay, show in browser. There it is, random color. Let's move it up here. Right, show there. That's good. And wait, whenever you see this flash, that means let's change the color here. FFF. Okay, so hold on a second. Let me change that. So what I'm doing is that whenever I refresh this page, you see there's a flash of the background. It was gray, then it becomes white. The reason is like that because I have the CSS here. It was the gray, silver. Then when the JavaScript loads, the default is white. So that's why you see the flash. That's no good. So let's just change this to white. Now refresh, you don't see that color flash. That's good. So now let's go back to our code here. We added a random button here, here, and now we need to add an ID. So let's do an ID then. Okay, so copy that, paste here, random color. button, let's say button random color. Okay, so that's our ID. Good. Then let's go to open the file. So this is this JavaScript file. This is actually TypeScript. I'm using TypeScript. Now TypeScript is just a superset of JavaScript. So you see, basically the whole thing is JavaScript. The only difference is that you see this thing here, the HTML input element. That is from. You can kind of ignore it. TypeScript is a statically typed language, and it's very useful. Like I said before, it's very useful because when your program is large, it helps in avoiding errors, coding errors. So anyway, so we just added a button for random color. Right now, there's no action. So first of all, we need to get the button element. Let's smaller. Okay, so let's say button random color. Okay, so get element by ID, then we get that element, we assign it to button random color. Then so we got the element then we need to add a event, meaning that when people press the button, something some function is called. So let's add the event here. So button random color add event listener, and we call the function update. Now the function update is defined here. So the function update, basically it gets all the parameters from user, all those colors, x, y, this offset and blur values, get all those values, then convert it to a CSS syntax. So you have this result string. This is a CSS syntax. Then you just add it to the style box shadow. Add it here, and also create a string, box shadow string, and add it to the content. So that's how we got the text here, the CSS syntax. So that is how update is done. Now remember, now we have a random color. What we want to do is so we got a button, and we also got a event. So when user click it, it'll call function update. Now what will this button do? Of course, it changes the color. First of all, when user click it, it should also change the color here. Let me show you what you mean. So random color, let's see. So we go back to the code, the function update. Then we say constant random color, okay, equals to, oh yeah, then we need to generate we need to generate the random color string. Luckily I have done that before. So how do you random hex? Yeah, so we have done that before by just, you can go to CSS linear gradient, same thing with radial gradient, random direction. So here there's a random color button, so we can just open this file and get the code from there. So search for JavaScript, search, yeah. So here is the CSS linear gradient code, and so we have this code here. Let's magnify. Okay, we have this random int. It generates a random integer from min to max, Then we have the random color string. That's what we want, this function. Let's copy it. Let's get those. Close it. Close it. Now we are back in our box shadow code here, and let's insert it. So we got these two new functions, random int and the random color string. So how they work, random int just give you a random int. So the way this works is that first of all we create a function that that generates two hexadecimals. Let me get this so that it's easier to see. Okay, so here is the code. It's easier to see now. So this random color string, first of all, you define an inner function that generates two characters by calling the toString 16. Then, if it returns a single digit, you just pad it, a 0 in front because you need two hexadecimals. So this function returns two hex digits. Then you just return the string, call it 3 times, with a pound sign in front, so that signify color. So that's how you get a random RGB color string. Okay. So now we have that function. Now we can assign the value to the random color. We just call this function. Right. So random color will get a random color string. So how do we then what? So the random color actually should be the value of shadow color, because remember let's go back to the CSS box shadow. You see, the color will be used for the shadow. So we have a issue here. So when people click on the random, the shadow color should be, it should be set to the shadow color value. But now the problem is, how do we, so when we click, you have to actually find out when people clicked on it. Wait, hold on a second. So anyway, for now, let's do this. Let's comment this out. Wait. So we have two things here. Copy it, comment them out, and let's actually just put this there. So every time the shadow color is just random. Okay. Now we compile the Typescript. Okay, it says cannot redeclare blocked scope variable random color string. Okay, we must have declared it twice. Oh, we have. Oh yeah. Oh, I already have the code there. So we don't. We have the code twice. So yeah. So that's what we do. So we remove that. Okay, compile it again. Correct, no error. So reload the page. So you see, every time I reload, it's gonna give us, reopen. Every time we reload, it's gonna give us a new color. But that's, but what we want is when user click on that. Okay, so here's what we need to do. So we need to declare a global variable shadow color. Okay, let's declare a global variable shadow color. Okay, and it's not constant, it's a what's going on. So we declare a global variable shadow color. Then for the random color button, let's go down to the event. So when random button random color is clicked, it should call a function that update the color, not render the whole thing. It just set color. Okay, it will call the function set color, and we are going to define the set color here. Constant arrow function set color. Okay, it will take no arguments, and it will return a hex color string. So we're gonna call random RGB color string here, and it'll be, yeah, so that's it. So actually we need to do it like that. So the set color, oh wait, this is wrong. So actually we need a block. So color equals to that. So we got a color, we got a random color here, a string, but you also need to change the shadow color input box here. It's a nice touch, because when you click random color, the it shows random color here, but it would be nice if the input also changes, because otherwise it's inconsistent, right? Like right now you have one pink and one orange. So we need to update the shadow color. That's easy. Okay, so the shadow color item, we can see on top, it's the color picker element. So color picker element value equals to CL, let's say run color. Okay, there. So we get a random color, and we assign it to the input color picker. And oh wait, actually what we should do is we should assign it to shallow color. Let's do it like that. Yeah, so we get a random color, we assign it to shallow color, the global variable value. Then we also assign it to the color picker input. Then in the update part, we don't need the shadow color anymore because it's already defined here. But also, when you, okay, let's try to compile the code. Okay, so compile the code, it says successful, no error. And now let's see what happens. Refresh. Okay, apparently there's an error, so let's open console log, refresh. Okay, no error here. Those are, those errors are from Google, ads. So anyway, so we don't have any error here. However, it's not showing, so there is something wrong. Oh yeah, when you refresh, you see that's a problem. When you refresh, the shadow color is not set, because nobody, update, it's not set in update code. It's only set by this function f set color. but however nobody has called fset color, so we need to call it. So we just call it here. You know, we call the set color, then we call the update. So now we compile the TypeScript code and back to the browser, refresh. Yay. Yes, yeah, default state to begin with. So it looks like we got it working. So we click, let's try. No, we click random color and nothing happens. Oh yeah, because in a random color, when it's clicked, remember we set it to call the set color function, but we did not update the whole thing. So we also need to update the whole thing. So let's say, so when random color is clicked, we need a function that we'll call set color, then call f update. Yep. So let's compile the code. No error. That's good. Let's refresh the browser. Now let's try it. Click. God, what's wrong? Wait, so button random color, set color, and update. So what is wrong? Okay, the manual setting color also is not working. Click event. Oh yeah, you are right. Thank you. Yeah, click. Great. Uh, hey, wait. Okay, that's the right direction, but there's looks like there's still something I did wrong here. Wait, click. What's going on? Click set color and update. Did we? Oh, compile TypeScript. Update. By the way, Sean, are you using any framework? Like, do you use any framework like or any JavaScript libraries you use often? So what's going on with the set color? So set color, then update. Set color, show color. Oh, just JavaScript. Okay, just learning. Yeah, I never got into using the frameworks, but right now I'm kind of trying to, I'm kind of learning the React JS. I actually studied React JS for a few days, for a week, a few months ago, and I think it's very good. Um, but I mostly still prefer raw JavaScript, like for several reasons, for mainly two reasons. One is that I really like the fundamental technology. I don't like the wrappers created by some corporation because they can change anytime. They come and go actually. React seems to be the big one, that one of the top three major ones. React, Vue.js, Angular. These are the three kind of the major ones. But a few years ago there are lots of others. There are tons of others. They come and go, and each one is like they are different. Yeah, they obfuscate. Right, yeah, because and they are this, especially in Java. JavaScript is very different from other languages. I mean, the JavaScript industry, because in other languages, in C, I don't know C or C++, but I, in Perl, in Python, in Ruby, in Golang, you can use libraries. The libraries looks the same as, you don't have to learn, like extra. But in JavaScript, when you use a framework, it's like they introduce it's like you are learning a entire different syntax and also entire different semantics, the model, like the uh, MVC, whatever, that crap, MVC, like every framework you are learning entire different thing. That's not good. Yeah. So anyway, so let's try to get this to work then. What's going on? So let's print. When something is wrong and you don't know what, the easiest way to debug is always just print the value. Let's say show color, show the shadow color. Now refresh. Okay, it's printed. Okay, now but if I click random, oh, it's working. Oh, I guess I didn't press refresh before, maybe. Oh, right. But this part is not working. Okay. Yeah, so when user manually select the color, it's not working. We still need to do that. So when user manually select the color, okay, I guess what we have to do is just like before. Okay, originally we need a value. Let's see, color picker, show bar color picker value. Okay, so here we initialize it to a value, but when user okay, let's write another function. That's user update color. So let's change one of the function random. Okay, fset color random. Then we have another function, so fset color random here. Okay, so when user click random number, we have we call this function. But when user click the color picker, we need to call set color. Let's say set color user. Okay. Well, actually, we need we need the whole line. Let's do like that. And oops, let's do like that. So like that. So when color picker is clicked, we have the event click. Oh yeah, click. We have the event click. Then it will call set user color, then update. Okay, that seems good. Set color user. Okay, so let's go to the function here. We modify the function here. The function will be just get that. Okay, then color picker value, we don't need that part. Right, so shadow color equals to yeah, that looks right. So let's evaluate it, compile. Success. Okay, let's see if it's a success. Refresh. Looks good. Random color looks good. Let's make it big. Let's make the default blur bigger. Close this. Let's make the default click, and let's it's here. blur and spread. So blur value equals to, let's say 20. Okay, refresh, random color, and color picker. Ah, wait. Let's refresh. Color picker. No. What's going on? Open the JavaScript. Compile it. So color picker. So when color picker is called, when color picker is clicked, it sets a color value to the shadow color global variable. And the shadow color global variable, the color picker, it's kind of new. It's not there, in the year 2000s. I don't know when was it added, but it's kind of new. So, but I think the problem is our code. It's probably not. The problem is our code. The color picker, you just say type equals to color. I discovered that. But anyway, that seems to be robust. Because it's part of the browser. I cannot imagine they have a bug. The problem seems to be, wait, something happened here. The problem, I think it's our code. Wait, it worked? Okay, there is something wrong here. Only when you click. Oh yeah. So when you, here's what happens. Let's say red. Okay. Wait. Let's say refresh. It looks like you have to do it one time first, then it updates to the last color value. When you click off the picker, it updates. Yes, I mean, it updates. There's something wrong. It's not updating the thing here, you see. It's only updating the user input box. But that's from browser. That behavior is from browser. It should, also update here. So let's print set user color console log shadow color. Compile it and refresh. Random color is working, but when you click shadow picker, so let's trace, let's find out what's going on. Click shadow picker. This is weird. Click shadow picker green, then close it. Oh, I think maybe here we need to say, instead of click, and we need to say input. Oh yeah, for color picker you need input. That's right. I'm pretty sure that's a problem. So compile the code, back to browser, refresh. Random color works. Now color picker. Yeah, so we can like smoothly drag and have color change. That seems, so it's working. So yeah, I think that's great. So that's great. We got it working. I think that's it for today. Let's say console log. Remove the console log. Compile the code. So compare the code. So you see, so here is the TypeScript code, and let me show you the compiled code. Have you used TypeScript before? So compile code, TypeScript, so here is the JavaScript code, the TypeScript generated. Basically, it tries to it basically maintain your formatting, your indentation, everything. Well, actually, it indents for you, but it maintains even the line numbers typically often. Well, not actually, no, but it tries to, though. It doesn't reformat all your code. So anyway, so here is the generated code, 60 lines of code. So I think that's it. This I think this code is actually the final form. There's no I don't there's no, I mean, usually we can refactor, like touch up, see if there's anything we can clean up or things like that, but in this case I think it's pretty good. Yeah, TypeScript, TypeScript is very useful for for when you have large amount of code, like over 1,000 lines. Then it really helps by specifying the type. Yeah, let me show some of the complex TypeScript code I have here. For example, here you see, for example, you can see this line of code. It's adding two vectors. It takes two arguments, two vectors. Like the first argument is array of two numbers. The second argument is also another array of two numbers. Then it just add them together like this: a1 plus b1 and a2 plus b2, array of two numbers. So in normal JavaScript, you would say like that. Let me show you. In normal JavaScript, you would not have that. It would be much simpler. You see, you just have these. But in TypeScript, so you started to add types. So this first vector array is array of number and number. Same thing with the second argument, and the return result is also array of two numbers. So you started to add all these types. It can be actually tedious, and also the code becomes sometimes unreadable. For example, when you have lots of the let's see, for example here, when you use the let's see, let me show you the destructuring argument in JavaScript. JavaScript functions this argument destructuring. Like for example, like default argument, or when you have it gets complex. Anyway, that's that's a TypeScript. You have to add those, but it really helps. I wanted to say there's another great advantage is that when you like JavaScript these days, there's new version every year, but the browsers you typically do not support it until 1 or 2 years later. So if you want to use the latest feature of JavaScript, you can use Typescript. It will just compile, you can use the new features. It will compile to, the previous version of JavaScript. You can specify, which target version of JavaScript to output. Anyway, okay, so yeah, so thank you for watching. Thank you, guys, for watching. So that's it. So have a good evening, Sean. Bye.